Good afternoon, everyone. Myself, Dr. Atul Agnihotri, Assistant Professor in Khalsa College of Engineering and Technology. I am taking the mechanical engineering subjects of BTech Mechanical Engineering. I am teaching their heat transfer, and today we are discussing some basics of heat transfer. Heat transfer originated from the very important subject thermodynamics, which means the dynamics of heat, right? Heat, what is heat? First we have to understand the heat. And what is heat? Heat is originated from the energy. It is the basically it is the energy. Suppose we have a this hand is at high temperature, this hand is at low temperature. If we combine, the heat from high temperature will come to the heat to the low temperature, right? So both will have, both hands will come after the at the same temperature. It will achieve the equilibrium condition. So heat transfer is very important subject from the mechanical engineering point of view, in because very important components of heat of power plants engineering equipments like boilers, like condensers, like turbines, okay, superheaters, reheaters, all the applications of the heat trans so mechanical engineering point of view, it is very important. So we cannot neglect the basics of heat transfer, right. So there are three modes of heat transfer. First is conduction, second is the convection, and third is the radiation. Conduction, in what is conduction? Conduction, suppose we have a solid body and we applied the heat at this place, right. We applied the heat at this place. The solid substance is made of very tiny molecules. The molecules will aggregate, they will gain energy, and they will try to vibrate. They will vibrate and they will pass on their energy to the another set of molecules. They also get vibrate. Similarly, the chain will start the passage of energy to one molecule to the energy through the vibrations, right. They will attain some kinetic energy, which will increase their kinetic energy as well as their potential energy. This will increase their internal energy, and we at the person holding the pen at this end will feel the sensation of warmth. So this is known as the conduction. Suppose we attach another body with this pen and apply this heat. Suppose this is warm and this is cold. We apply the heat at this end also. So this will also get warm due to the conduction, because the conduction of the particle, they have transferred their kinetic plus molecular energy to the internal energy have gained. So because internal energy is function of temperature, as the temperature will increase, internal energy will increase, right. So the conduction phenomena will happen with this from in the solid particles. Similarly, in the convection process, in what is convection process? Suppose there are some convection currents. First we will understand what is convection. Convection is the surface is the heat transfer mode in which there is no physical contact, but suppose this is the very flat plate and it is very it is heated, it is at high temperature. Suppose a cold air comes and touches the surface and leaves. Cold air comes, touches and leaves. The air will gain some kinetic energy, air will gain some high temperature. So this is the convection process, not in the direct contact, but vicinity of the layer passing over and it is get heated, right. So this is the convection process, no physical contact, but it is heated. This is the convection process. Other is the mode of the radiation, is the radiation is the third mode of heat transfer, in which there is no intervening medium is required. Like conduction and convection, there is no intervening medium is required. Suppose this is these are the lights which are emitting the radiation towards me. I am feeling warmth. Suppose we have sun at the outside surface and we are feeling warmth. So there is no intervening medium. The energy is coming in the form of packets, in the form of photons to us, and giving us the sensation of warmth. So this is the radiation exchange, radiation mode of heat and transfer, right. So first we go to the some basics of thermodynamics also. There is steady state and unsteady state. Steady state, suppose you live in an area where some river is flowing to, very near to your house. and when you are very small, up to 1 or 2 years kid or 3 years kids, the river was flowing with the same pace, same velocity and same pressure. And now you have experienced some age, you are gained some age, now you are 15 years old, you are 20 years old, and you go to the same place, and same river is flowing with the same energy, same place, same velocity. So the conditions have not changed with the time, the conditions are constant, they are not changed with the time. So this is known as the steady flow, right? So if the conditions were changed with the time, they were unsteady flow, right? So there are two processes, first is the equilibrium process, other is the non-equilibrium process. In equilibrium process, suppose equilibrium process, in thermodynamics is the main subject which deals with the equilibrium process, whereas in heat transfer there is no equilibrium process, but you can flow, you can predict the rate of heat flow, that how heat will travel, and at which pace it will travel, at what time the heat will be there in that content, you can predict with the heat transfer. But this is the main difference between the thermodynamics and heat transfer. You cannot predict the actual heat flow in thermodynamics, but in heat transfer you can predict the actual heat transfer, actual flow, heat flow rate, with the all with the beauty of the Fourier's law, with the beauty of Biot's number, all these things, right? So in a power plant, if you have students have noticed that in power plant we have a number of equipments like boilers, like superheaters, like reheaters, and then we have a nozzles, then we have a steam turbines, after that we have a condensers. They are very important and very costly equipments which needs kind attention, that how the heat will travel, the how we have to design according to the heat transfer, right? So heat transfer, that's why heat transfer becomes very important from the mechanical engineering point of view, right? And we in the trending area we are using some softwares like ANSYS, like Fluent, they are also dependent upon the heat transfer, they help us to determine the heat transfer flow rate, right? So heat transfer, so to understand these softwares, to understand the power plant engineering, the heat transfer is very important subject. So we start with the first we start with the Fourier's law. Fourier's law of the is developed by the scientist Fourier, J.B. Fourier. He stated that heat can be transferred from high to low temperature, and heat flow rate is directly proportional to the temperature gradient. If the temperature gradient exists, then the heat will travel from high to low temperature, right? So to remove the proportionality sign, he introduced one constant known as the K, thermo, that is the conductivity coefficient, right? That is also known as the conductivity coefficient. So according to Fourier's law, Q is equal to minus Ka dt by dx. So what is A? A is the cross sectional area, not the surface area, this is the surface area, but cross sectional area is this, right? So temperature gradient is this, from this temperature to this temperature about over its length, right? And area is this cross section area. Then we have discussed about the convection. Convection is, it is jointly formed, the equation is jointly formed by the Newton and Rickmans. The Newton Rickmans law is the Newton law of cooling. It said that heat will transfer from the surface, so it depends upon the surface area. Suppose the air is running over the surface, it is equal to heat transfer is equal to HA delta T, temperature of the surface over the fluid is that is flowing over the, that is temperature of fluid, right? Then again the very important law in the radiation also, the energy emitted by any body is equal, suppose this is the black body, energy emitted by the body is equal to directly proportional to the fourth power of the temperature emitted by the body. So it is equal to sigma A T4, sigma is equal to sigma 5.67 10 to the minus 8, that is the Stephen Boltzmann constant. Okay. So all these are the various laws which are very important from the heat transfer, right? So again we come to the some basic concept like absorptivity and then transmittivity and then reflectivity. First we discuss the black body. What is black body? You have seen some solar cookers, some very black furnaces. That is all about the black body. Black body is a body which absorbs all the radiations, all the electromagnetic waves which are coming to it. They are all absorbing, right? So alpha, that is absorptivity is noted by alpha. Area, not area, it is the heat transfer divided by the total heat transfer. So we were discussing about the black body. So black body is a body which absorbs all the radiating heats coming to the body, and they are absorbing all the heat and emitting some heat, right? So its alpha is equal to 1. Theoretically it is ideal body, it is not practical body, it is not possible, right? So what is alpha? Alpha is the heat transfer energy or energy coming to the body over total energy absorbed by the body over total energy incident, and alpha is equal to 1, right? Similarly there is one reflectivity. Reflectivity means the energy is coming to the body and it is reflecting to the other side, to the when it is coming and it is reflecting. This is the reflectivity. Similarly there is transmittivity. Suppose this is a transparent surface, the energy, the electromagnetic waves are coming and then passing through the all, right? This is the transmitted. So these are three properties of the radiation, right? So coming back to the heat transfer, you have one, I give a very practical example to the students. Them, when a person is running a marathon and after when it comes very near to the final touch and he runs very fast, he or she runs very fast, and when he crosses the main line, they the supporters, they covered him with a very shining material. Why? Because the after running so much, the energy is emitted by the body. The energy is emitted by the body, and if all the energy will get emitted by the body, the person can lose all the heat and his body can become very cool. So he can lose his life also because all the energy will lost. So the concept behind saving the person is they covered him with a very shiny shawl or shiny cloth. What shiny cloth do? They will, what shiny, the energy that will be emitted by the body, the shiny will emit its same heat to the back to the body. So the person, the energy will get conserved, it doesn't get loosed, right? It doesn't get loose. Suppose we have a very suppose this is a very shiny body and we have this is a very dull body, right? And the all the energies are all, and they are kept in the sun surface area. They are kept in the area where there is too much hot in the June July month, and it get heated. This also get heated. The shiny surface get heated much, and this dull surface will be less heated. And where will you prefer to hold, shiny or dull? You will hold a dull, because the in shiny area it gets too much heat and it's too much heated, but dull place the movement of electrons is very less, so it doesn't take place at a very high rapid rate. So this all are the applications of the heat transfer. So we will this is a very important subject. This should be dealt in a very detail from the basics from the Fourier's law. So we will discuss in detail in the upcoming lecture. Thank you.